Good morning, friends. General Science, Class 8, Chapter 3, Force and Pressure, Part 10, Beyond Force. Let's see what is the beyond force with the help of simple activity. Take a plastic ball and place it in the water and see what happens. The ball floats on the water. Now push it in the water and see what happens. The ball again comes on the surface and floats on the water. Now take another ball. This ball is filled with water with the help of injection. Now leave it in the water and see what happens. The ball floats inside the water. The ball does not come on the surface and it does not fix into the bottom. This means that the force due to gravity acting downwards must have been balanced by an opposing force in upward direction. This force is called as beyond force. This force must be originated from the water surrounding the ball. The upward force on the object in a water or in a liquid or in a gas is called as beyond force. The upward force acts on an object in a water or in any fluid or in a gas is called as beyond force. Let's see. Push the ball in the water. Now you feel that it is not easy to keep it in the bottom. Some force acting on it. You feel it as you release the ball comes on the surface and you feel that some force exert a force to come out on the surface. This force is called as beyond force. Example for beyond force. While pulling a bucket from a well, the bucket full of water immersed fully in the water appears to weigh less than when it has been pulled out of water. Why? Let's see with the help of simple activity. Take a glass and take a plastic bottle. Sand is filled in this bottle and it is connected to the pen. Now place this bottle inside the glass and see the tension of the rubber band. Now this bottle is not touching to the base of glass. Now slowly pour the water in a glass and see what happens. At the same time you have to see the tension on a rubber. The tension on a rubber slightly decreases the length decreases and the bottle coming to upward direction. Now you have seen that the tension decreases, length of rubber band decreases in a water. What does it mean? It means that when the bottle in a water, the water exert a force on a bottle, and this force is called as buoyant force. And hence, when the bucket in a water fills way less, and when it was outside the water, it feels heavy. Take a piece of aluminium sheet and place it in a water and see what happens. It deep in a water. Now take another sheet and shape it like a ship, like a boat, and place in a water and see what happens. It floats on the water. It floats on the water. Why? It is easy to swim in a sea water than fresh water. Why? Because the density of sea water is greater than the fresh water. Salts are dissolved in it, and hence it is easy to swim in a sea water than fresh water. Explanation. When a sheet of aluminium is placed in a water, it sinks in the water because the density of aluminium is greater than the density of water. But when the same piece of aluminium sheet is shaped in boat-like structure, then it floats on the water because it displaces large amount of water, and the buoyant force of water balances the weight of boat, and hence boat-like structure floats on the water. An iron nail sinks in the water because the density of iron is greater than the density of water. And why does large, massive steel ship floats on the water? Because ship displaces large amount of water, and the buoyant force of water balances the weight of ship, and hence it floats on the water. Buoyant force depends upon two factors. Number 1, volume of the object. The buoyant force is more if the volume of dipping object in a liquid is more. And number 2, density of liquid. The buoyant force is more if the density of liquid is more. How it is decided that when the object left in a liquid will float on the water, or sinks in the bottom, or floats inside the water? Is there any relationship between buoyant force and weight of object? Yes, there is a relationship between buoyant force and weight of the object. The object float on the water. If buoyant force is greater than the weight of object, the object float on the water. If buoyant force is greater than the weight of object. Number 2. The object sinks into the bottom. If buoyant force is less than or smaller than the weight of object. The object sinks in the bottom if buoyant force is less than the weight of object. And number 3. The object float inside the water if buoyant force and weight of the object are equal. The object float inside the water when the weight of object and buoyant force are equal. Thank you very much.